All right, well, welcome to our first Speaking of Water talk of 2025, evaluating the efficacy of nature-based solutions to urban water challenges. I'm Dave Feldman, I'm the Director of Water UCI, and it is my pleasure to welcome Dr. Monica Palta, who is Assistant Cooperative Extension Specialist in Urban Water Quality, Health, and Justice with UC Agriculture and Natural Resources. Dr. Palta is the first cooperative extension specialist to be based at UC Irvine, and she holds joint appointments with the Samueli School of Engineering and the School of Social Ecology at UCI. She received a Bachelor of Arts in Biology from Grinnell College, an MS in Ecology from the University of Georgia, and a PhD in Ecology and Evolutionary Biology from Rutgers University, and has conducted postdoctoral work at Arizona State University. Prior to coming to UCI and UCANR, she was associate professor in the Department of Environmental Studies and Science at Pace University in New York City. An urban ecologist and biogeochemist, her research is focused on wetland, river, and stream systems. In her new position with UCANR and UCI, she is undertaking work in forming resilient and equitable urban water resource management in Southern California. Before we begin, I want to take this opportunity to thank the staff of Water UCI, Kayla Vion, our Communications Director, and Chanduk Gim, our Associate Director, for their effort in organizing this colloquium. And I also want to thank Mimi Cruz and Han Parker with the School of Social Ecology for their assistance in organizing this event. Following Monica's talk, there will be a moderated Q&A system. There is a Q&A box where you can write your questions. I'll call on those questions whenever we have available time after the talk, and we'll go through as many of those as possible. With that, it is my great pleasure to welcome Monica Palta. Monica, it's all yours.
Thank you so much, Dave, for that great introduction. I'll be talking today about work that I've done in many parts of the country, as evidenced by Dave's background that he gave on where I've done work and where I went to graduate school, etc. So I'll just launch into the sort of overarching through thread of my work, which is that the relationship between people and water is exceedingly complicated. So on the one hand, our earliest cities and earliest civilizations developed on river floodplains. So in this rendering of what early Mesopotamia might have looked like, you can see the myriad uses that humans have of the river floodplain. In various ways, humans are, of course, requiring water for drinking, but also for supporting their hygiene, so bathing, for growing food and supporting agriculture, for transportation, and so forth. And humans have continued to develop their cities and dwellings along waterways. So we can see on the left-hand side of the slide how urbanized many of our watersheds in the US are. And even here in Orange County, we are situated on a number of river floodplains. And this development, of course, brings us the needed resources and services that freshwater and river floodplains provide, but of course can create a host of problems and undesirable impacts on those water resources. So if we compare the natural water cycle to the urban water cycle, we can see that in natural areas, water cycles through the environment as a gas, in gaseous form and liquid form, and is therefore, in some sense, renewable. So we, have evaporation into the atmosphere, deposition again through precipitation, and so our freshwater bodies are renewed in this way. In the urban water cycle, though, we have some key alterations, one of which is that because of all of the impervious surfaces, all of the paved areas that we have in cities, there's much less infiltration of water, which can limit the ability of groundwater stocks to replenish. And this impervious area also results in greater runoff. So we see less water infiltrating into the ground and more of it running off the surface of the land and into waterways where it makes its way to the ocean. Another key difference that we see in cities is the fact that water is moved around through the landscape, not through these sort of natural fluxes like you saw in the last slide, but through infrastructure in order to deliver it to human populations for use. So we have sewer systems that take care of wastewater. We have drinking water treatment plants and delivery systems to get water into dwellings. We are using water for urban gardening, for urban agriculture, and of course, ways in which we are trying to recharge the infrastructure to recharge the aquifer or deliver wastewater to different water bodies. And so there you can sort of see how these key differences in the way that water moves through the landscape and is used in urban areas can create a number of problems. So we have this sort of unnatural linearity of water flow in cities where we are drawing water from other parts of the landscape. As you can see in this map of California, the bigger circles are where drinking water is sourced from. That is usually far away from cities. So we're drawing in water from other parts of the landscape, bringing it to cities through infrastructure, and then usually disposing of the water after it turns into wastewater after human use into waterways, which then goes into the city, which means that it's not necessarily a renewable or sustainable resource because the water is coming in from other parts of the landscape and leaving as pollution. Interestingly, though, in Orange County, there are some efforts to change this, for example, by recycling wastewater back, sometimes into the groundwater and even in some places in LA County, back into drinking water. Because of the infrastructure in cities and all that impervious surface, which again limits infiltration and causes excess runoff, we have flooding issues in cities as well. So we have a water quantity problem that emerges during rain and extreme events. And then we also have a number of socioeconomic inequalities in our cities that create vulnerable communities that are disproportionately affected by environmental hazards like poor water quality, contamination from wastewater, and flooding issues as well. So my work has really focused on the use of nature-based solutions to mitigate some of these problems and improve this complicated relationship between people and water. And nature-based solutions are defined by Wild et al. As these cost-effective solutions that are inspired and supported by nature. And they create what we call ecosystem services, which are benefits that the natural environment provides to people, and also build ecosystem resilience to major stressors like climate change and urbanization. And so in this talk today, I'm going to be telling a tale of two metro regions. I'm abbreviating nature-based solution as NBS here. And the main research questions that I have explored in these two metro regions, namely Phoenix, Arizona, so the Phoenix metro region, and then New York City, the New York City metro region, is what controls the inputs of nutrients and microbial pollution in urban watersheds? When is management of nature-based solutions useful and when is it not? And how do nature-based solutions provide ecosystem services and disservices to vulnerable communities experiencing environmental stressors? So those are the main research questions that I had as a postdoc and as a faculty member and graduate student in the New York region. But my new job is, as Dave said in his introduction, as a cooperative extension specialist. So for those of you who are maybe less familiar with what cooperative extension is, my job is to carry out collaborative transdisciplinary research that is also community driven and engaged, because my job is really to be a liaison between academic research that is happening at UCI and end users of the research. So as Dave said in his introduction, my job really focuses on water management for long-term resilience and reliability to meet community and ecosystem water needs. And so some of the issues that I'll be tackling are around drinking water, wastewater, and just sort of generally speaking, watershed management. So attempting to use nature-based solutions, for example, to mitigate floods, improve water quality, and try to facilitate this more sustainable and resilient relationship between people and water in Orange County and beyond. So for my extension program, I'm really interested in how we develop more informed community decision-making around managing urban water quality and quantity, how we can ensure that management and policy decisions reflect community uses, values, and desires, and also how we can manage urban environments to minimize harm and maximize benefit and access for vulnerable communities. So I'll be speaking about some of the work that I did in Phoenix and New York City that was somewhat extension adjacent, I would say. I was not an extension specialist yet, but I was carrying out this kind of work and was very excited to take this position as the first cooperative extension specialist at UCI to kind of continue the work that I had started undertaking in New York as faculty there. So I'll first talk about my research on the controls of the inputs of nutrients and microbial pollution to urban watersheds. And I want to talk first about the impacts of nitrogen pollution. So my work has focused a lot on nitrogen pollution and nitrogen pollution mitigation. And not everyone is familiar with why nitrogen is potentially damaging to people and ecosystems. So we see some of the adverse effects of nitrogen pollution in Orange County and throughout California. One potential problem is that nitrogen, of course, is a nutrient that fuels plant growth. And so when it gets into waterways, it can fuel excess growth of algae in waterways. So nitrogen has caused these algal bloom problems, for example, in Newport Bay. And what happens when we have these excessive algae blooms is not only does the algae start decomposing and thus stripping the water column of needed oxygen for wildlife, but it can also release toxins in some cases that are harmful to wildlife and to humans. And so and as recently as 2023, harmful algal blooms in Southern California were leading to sick and dying wildlife throughout the coast as a result of these algal blooms. Additionally, elevated nitrate in drinking water can cause health problems, particularly in infants. And in this map, you can see by the Environmental Working Group, they showed the red colors are drinking water wells that had nitrate levels exceeding drinking water standards, multiple times over a decade or so, several decades. So these are all potential problems that we need to address and get ahead of. So nitrogen is definitely a pollution problem from agricultural areas. Many of you may be familiar with how fertilizer in agricultural areas leads to elevated nitrogen in water, but nitrogen can also be quite abundant in urban areas. So treated wastewater and untreated sewage can be a major source of damaging nitrogen, fossil fuel combustion. Of course, fertilizer application happens on lawns in cities as well. And even leaves from street trees can be a net source of nitrogen. There's been a lot of work done in the Twin Cities in Minnesota on how leaf packs, leaching of water from leaf packs can lead to excessive nitrogen and phosphorus ending up in urban lakes where it additionally causes algal blooms. In New York City, where I worked for 7 years, the combined sewer overflow system is a major source of water pollution. So this is an older wastewater system that combines rainwater and wastewater. So during dry weather, wastewater generated from homes and businesses flows via gravity to a sewage treatment plant. But because the storm drains also feed into the same system, when you have a heavy rainfall event, the volume of water exceeds the capacity of the wastewater treatment plant and the pipes. And so you have an overflow into waterways of raw, untreated sewage. So as you can imagine, this causes a lot of microbial pollution. So this is work that I did with a student in Coney Island Creek in southern Brooklyn, where you can see that rain is tied to the number of pathogen indicators that you find in the water. And there are a number of stormwater outfalls, these MS4 outfalls, and combined sewer overflow pipes that are definitely causing this correlation between rainfall and microbial pollution. I've also utilized budgets, nitrogen budgets to identify the major sources of nitrogen pollution in New York City, which is a sizable pollution problem there. And so this is work that a student of mine did that identified, if you look at this pie chart, this breaks down the various contributions of potential sources of nitrogen pollution. You can see that almost 100% is from raw sewage that is coming out of the combined sewer overflow system and treated wastewater. The wastewater treatment plants in New York City don't have the technology to remove nitrogen. That's not true in every municipality. In Orange County, for example, they do remove nitrogen, but in New York City, we have a sizable contribution from those two sources. Interestingly, water quality monitoring that I carried out in Phoenix also showed a very strong correlation between rainstorms and pollution loading. So this is a city that does not have a combined sewer overflow system. There are separated stormwater and wastewater pipe systems. But even so, we see during rain, so the top graph is showing precipitation. There's these prolonged dry periods followed by a summer monsoon and a winter rainy season. And we can see that both pathogen indicators in these stormwater pipes, as well as nitrate levels, are spiking, particularly in this first flush after a prolonged dry period. We see a very high loading of those pollutants. And I'll point out that the pathogen indicator graph has a log scale on the left-hand side. So you can see that it's orders of magnitude higher when it rains. So all of this is to just sort of contextualize further some of the issues that we face in cities, that we not only have these pollution problems, but also potential interaction with extreme events linked to climate change. So this graph is showing total nitrogen export from various watersheds in both urban and forested areas in Baltimore over the course of almost a decade. And we can see that extreme events that we are expecting to be more frequent and more intense under climate change are causing greater export of nitrogen pollution from urban watersheds than forested watersheds. So this record drought followed by a tropical storm shows very high loading in the urban watersheds, whereas the drought and the storm are somewhat buffered in the forested watersheds in terms of the nitrogen export we see coming from there. And I think this points again to the importance of turning to nature-based solutions as a potential source of mitigation. We see that natural systems are much more resilient and much better able to handle extreme events and somewhat buffer not only water quantity issues but water quality issues. So this really points to a problem that goes across different regions of the US. In the Northeast, the climate events that we worry about becoming more extreme under climate change are things like drought and hurricanes. And combining that with urban infrastructure, like combined sewer overflow systems and impervious surfaces, as well as land change and land use, we really have this extreme interaction that we have to plan for. In the Southwest, so for example, the data set in Phoenix that I showed you, we have potentially more extreme droughts and extreme rain events during the monsoon season, as well as wildfires, as we've been seeing sadly in this last month in California, that are contributing to potentially both water quality issues and water quantity issues. So this graph up here is a box and whisker plot of the same data set that I showed you in the previous slide, where we're seeing during dry periods or base flow versus storm flow periods, we're seeing an elevated concentration of nitrogen in the stormwater pipes in Phoenix. So we know that there's a pollution problem in cities. In terms of extension, this aligns with, okay, how do we develop more informed community decision-making around managing urban water quality and quantity, given that we have this pollution problem that is likely going to worsen under projected changes in climate change. And for this, I'm going to talk about work that I did in the New York City area. So these brown dots that are going along the waterfront are all CSO pipes. So every one of those pipes is spewing raw, untreated sewage into New York City waterways every time it rains, to just give you an idea of the scope of the problem. And I did work with colleagues in the Harlem River, in northern Manhattan, and in Coney Island Creek, which I showed you in a previous slide. These communities are disproportionately elderly, disproportionately foreign-born, and disproportionately living in poverty compared to the citywide median levels of those vulnerable categories. So to further contextualize, why this is important for these communities and these waterways, I just want to talk briefly about green space accessibility in New York City. So New York City has a very sizable, coastal access. Along the waterfront are a number of public parks that are situated within these vulnerable communities. But green space accessibility is fairly high in New York City. So 99% of residents live within a 10-minute walk of a park in New York City, and that cuts across all income levels. So high, middle, and low income, as well as different age categories. So a lot of green space within walking distance. However, if we look at a breakdown of park space per person, relative to the city median in different kinds of communities, we can see that Asian and Black neighborhoods within New York City have less park space per person than white neighborhoods and Hispanic and Latinx neighborhoods. And so this points to a problem of, accessibility is high, but the quality of that green space can differ quite a bit for vulnerable communities. There's less total park space per person, so the parks are smaller, and typically the amenities are not as good. In addition to that, particularly for the parks along the waterfront, you have problems with water pollution. So my colleagues and I did a number of social assessments along within these parks, basically. I showed you the work that supported that these waterways are heavily polluted with pathogens and nutrients. But a number of observational studies and surveys that we conducted demonstrated a lot of uses that put people in contact with the water. So people are fishing, people are bathing, people are immersing themselves in the water. In addition to that, the communities were articulating very strong cultural meaning and importance to the local community. Again, the green space accessibility is high. The quality, though, is a little bit low in the total space. And this is really kind of the backyard for a lot of citizens of these neighborhoods, or residents of these neighborhoods, I should say. And so this really points to an equity problem where, there's equality of green space in the sense that there is, accessible green space throughout the city, but the quality of that green space and the ability of people to, understand some of the hazards associated with it is not equal. So how do we make the community more informed about the quality of their green spaces so that they can use it utilize it in a safe way? Because they really do value these spaces as places to recreate and spend time. So we conducted some surveys that did indicate a high concern of water pollution by disease-causing organisms. So there was an awareness of respondents that the water is contaminated, but there were answers to survey questions that sort of contradicted this, where about half of the respondents, you can see from this pie chart, felt that it was very safe or somewhat safe to swim in the Coney Island area, while the other half thought that it was somewhat or very unsafe to swim. So the responses, even though there was a concern about water quality, the uses that we observed there of fishing and swimming and the responses to the survey saying that people felt safe swimming there sort of contradicted that. And I think this really points to the importance of evaluating community uses of waterways and perceptions around water quality in order to, make a more targeted effort around developing community awareness. One effort that is being made that I think it can be very useful toward raising community awareness and facilitating better decision making is conducting citizen science, which is where members of the general public collect data, typically as part of a collaborative project with professional scientists. And this can really be a key mechanism for building community awareness around water quality issues. So my colleagues and I worked with the Billion Oyster Project, for example, doing an analysis of their monitoring water quality monitoring programs. So they have citizens go out. Their mission is to restore 1 billion oysters to New York City waterways. So they have people maintain these oyster reefs and also monitor them for water quality. And when we evaluated their volunteer program, we did see that there was higher literacy, engagement, and optimism around environmental issues the more frequently people volunteered. So this was a very good educational mechanism to inform public use of waterways and get people more engaged. I'll move on now to a second area of research, which is around management of nature-based solutions. And the nature-based solution that I have studied the most is urban wetlands. Urban wetlands are quite frequently used as a nature-based solution because they provide a number of benefits. They're able to mitigate flooding by dissipating water energy and storing water. They provide habitat for wildlife. They provide urban cooling, recreational opportunities, but importantly, they also are good at mitigating water quality issues and air quality issues. So they are capable of sequestering a lot of carbon, and there are special microbial processes that happen just in wetlands that are capable of removing contaminants like nutrients and specifically nitrogen. However, urban areas typically have lost a huge percentage of their native wetlands. So this is a map of New York City showing historic tidal wetlands in pink, all of which have been lost. Currently existing wetlands are shown in green. So over 90%, about 85% of coastal wetlands lost in the New York City metro area, and 99% of freshwater wetlands have been lost since the city first started being developed. So there's a lot of interest in New York City and in many cities that have lost, close to 100% of their wetlands in restoring wetlands because of all of the benefits that they are capable of providing to cities. And there are a number of different kinds of wetlands that we can find in cities. I'll just go through these categories quickly. So remnant wetlands would be wetlands that pre-existed urban development. These are wetlands that were there before humans started building a city there, and they just kind of remain in the landscape because they never get developed. You also have restored and constructed wetlands that are, either a wetland that was existing but degraded and rehabilitated in the case of restored, or constructed wetland, which is a wetland that did not exist previously. It's just completely constructed and put onto the landscape after the site was developed. But I actually came up with a fourth category of wetlands that you find in cities in the course of my research that I termed accidental wetlands. So what are accidental wetlands? Accidental wetlands have all the characteristics to delineate them as wetlands. Wetlands are typically delineated by the presence of water, special soil characteristics, and plant communities that are specific to wetland environments. And these accidental wetlands have all those features, but they are novel ecosystems. So they have different kinds of soils, plants, and water sources than you would find from a native wetland. So these are typically wetlands that have formed in abandoned areas of the urban landscape, often in areas that were previously developed and then, kind of left alone, like vacant lots. In this photo, you can see an accidental wetland that developed in downtown Phoenix under an overpass. So this used to be a dry riverbed. It was turned into a landfill. Then the landfill was capped, and basically water that is being shunted off of the urban environment to prevent flooding in urban areas. So stormwater pipes, etc. Carry this water off the urban landscape and into these abandoned areas. And when you add water to that environment, it starts getting populated by urban plants and starts supporting some wetland processes that would be supported by native wetlands. So they do result from human activities in cities, but they're not designed or managed to be wetlands or to support the kinds of ecosystem services that wetlands provide. And very understudied, like I said, I just coined this term and started exploring these wetlands in this publication in 2017. So there's some conflicting theories that we could come up with here. A big question driving my work is, do accidental wetlands support the same kinds of benefits that restored, constructed, or remnant wetlands would? So how do we tie this sort of gradient of intervention and human influence into the kinds of benefits that we can get from wetlands? So remnant wetlands and accidental wetlands tend to be intervened on less by humans. Restored and constructed wetlands are intervened on more. So on the one hand, it could be that restored and constructed wetlands provide greater services because they are designed and managed to provide services like water quality improvement, like flood buffering. But on the other hand, remnant and accidental wetlands kind of self-organized ecologically into a wetland ecosystem. So perhaps they are, by being less designed, they support more services than a restored or constructed wetland would, because they're less kind of disturbed and meddled with by humans. So a key function that wetlands provide is removing nitrogen, as I said in the previous slide. Don't worry about these complicated chemical formulas here. Basically, denitrification is the term that we use for a microbial process that turns nitrate, which is a environmentally harmful form of nitrogen, into nitrogen gas, and which is a fairly inert, like unreactive, harmless gas that makes up 80% of our atmosphere. So this is a process that happens a lot in wetlands. It's the reason that a lot of treatment wetlands are constructed by, for example, wastewater treatment plants to remove nitrogen because it supports this process. So during my graduate work, I was basically measuring these wetlands to see if accidental wetlands support microbial denitrification, if they support nitrogen removal. And I probably don't have a lot of time here, so I'll just say that I found that they did support microbial denitrification. So this is an accidental wetland that formed on a brownfield site that used to be a landfill. And I actually found that the highest rates of nitrogen removal were happening in these piles of fill debris and garbage. So that was kind of a crazy result. And it was enough nitrogen removal to basically remove all of the nitrogen pollution that was entering the site. I did similar work in Phoenix, where I measured nitrogen at an upstream and downstream point of these accidental wetlands. You can see that, again, these form on a riverbed. And so there are these kind of long, linear wetlands. So I sampled at an upstream and downstream point. And these graphs on the right are showing the fraction of nitrogen removed. So you can see in the upper wetland that close to 100% is removed both during dry and wet conditions. The other wetland is a bit more variable, but on the whole, found that accidental wetlands, yes, they do remove significant amounts of nitrogen from the water, which is good. So I continued this work in New York City, looking at accidental wetlands, but also accidental wetland features or communities. So, and additionally compared that against designed features in the city. So a number of different waterways that support both planned green infrastructure and restored marsh, but also accidental communities of, for example, mussel and marsh populations. So my students carried out work, comparing these different kinds of environments, restored, accidental, and found that, again, accidental environments were supporting denitrification, nitrogen removal, but additionally even higher nitrogen removal than some of the restored marsh areas. So this, again, really supports this idea that accidental nature-based solutions can also be, significantly functional, and in some cases even more functional than restored areas. Unfortunately, however, when we compare this against the scope of the pollution problem in these wetlands, the capacity of the marshes, both restored and accidental, to remove nitrogen is fairly negligible. So they're very highly functional, but the scope of nitrogen inputs to these systems completely dwarfs the capacity for removal. So this top graph, for example, is showing inputs of nitrogen to Coney Island Creek, and our estimates of outputs of nitrogen, like being stored in mussel tissue or denitrified under mussel beds, and it's completely negligible. The bottom graph shows the nitrogen load that we would find in Newtown Creek, both with and without green infrastructure in the watershed. There are literally hundreds of green infrastructure projects in this watershed, but there's absolutely no difference in the nitrogen load that's going into the creek. And I can talk more about why later if there are questions around that. So great news that these wetlands are functional. But not so great news that they're really not handling the scope of the pollution problem in these systems. All right, I'm going to skip this because I'm running low on time. So I'll just talk about work that we've done to ensure that management and policy decisions reflect community uses, values, and desires. Again, talking about work that was done in the Harlem River and Coney Island Creek. So we did work in Sherman Creek Park, for example, which is, again, heavily polluted with pathogens and nutrients. As in the Coney Island Creek study that we did, we found strong importance to the local community as green space for this system. But some potential future threats to existing uses by the community because of proposed infrastructure and development projects. So there was a proposed, this is just highlighting, what interviews revealed in terms of community concerns. So there was some significant concerns about commercial development and privatization of the waterfront. So there were two key projects that my colleagues and I were looking at. One was to create a ferry terminal in Coney Island Creek. The other was to build a private boathouse on Sherman Creek. Both would have significantly altered these public parks that were being used by the communities next to these waterways. And so there were a number of actions that my colleagues and I tried to do, writing reports to community organizations and managers, presenting to the community board, providing written testimony. But these projects were really being seen by the city as improvements. Greater ferry access, greater recreation opportunities that are coming out of these development projects. But they really overlooked the importance and uses that were already happening by the community. And so I think these studies really highlight the importance of formalizing the documentation of hidden uses of waterfronts in less conventional ways prior to and as a part of the planning process. So how is the community using this space? How are they valuing it? How do they perceive it? And really working with the community to try to develop that. So I'll just talk about some work that we did in these communities, specifically in Sherman Creek Park. We did a social assessment of the community using the park, where they expressed a desire to know more about restoration efforts and ecology in the park. And so my colleague and I and a group of students created QR code informational signage that went up around the park so people could scan it and learn more about the restored wetlands and about some of the water quality issues in the park. There was also a plan to restore a marsh in the park, this marsh area. And so we conducted this sort of sidewalk science where we went out into the community and asked them what kinds of waterfront pictures they responded to the most. And they actually did respond positively to pictures of restored and accidental wetlands, which is helpful in the design of this marsh area to know more about what the community desires. So since I'm running low on time, I'm going to skip this this third study. I definitely can go back to it. But some main takeaways, I think, from this work are that nature-based solutions, even those that are degraded and haven't been restored or designed, can support ecosystem services. But these services can be highly variable over time and can be paired with potential disservices. Monitoring and budgets can help us determine the net benefit of nature-based solutions. For example, are these nature-based solutions handling the broader scope of the problem, in this case, water quality? But management goals for vulnerable populations may need to be different. And co-development of research and management with communities and managers is exceedingly important. So I'll end just talking briefly about some projects that I'm planning on undertaking in Southern California. One I've already started on community landscaping practices and urban water quality and quantity. So how different landscaping practices and this upcoming statewide removal of turf is going to impact various things like urban heat island, but also water pollution by nutrients and pesticides. I'm also interested in exploring nature-based solutions further for mitigating urban water quality and quantity problems, and continuing work with wetlands in the area, specifically San Joaquin Marsh and some of the restored wetland areas in Irvine. And then also, again, continuing to work on these hidden uses of urban green space and managing urban water resources to maximize the benefit and access of water resources for vulnerable communities. So I'll end there. I'm happy to talk about that third study more if people are interested on the use of accidental wetlands by communities experiencing homelessness in Phoenix. That was kind of the last piece that I was going to talk about. But please feel free to check out my publications on ResearchGate. And I'm on all of these social media platforms.
Fantastic job, Monica. Really a comprehensive and wonderful overview of your previous work and your aspirations for current work. Let me remind you all about the survey. We have one question in the chat and one comment. I'm pleased to see that a comment, John Peng is interested in working with you. John, I've shared Monica's email, so please do be in touch. And an anonymous attendee asks, the effect of wetland riparian bird species is often overlooked. They could easily reseed accidental wetlands. After that, then the most adapted plant species would be the most successful. Perhaps human intervention is not the only pathway to wetland restoration. Just a thought. Any reaction?
Yeah, okay. So the first part with birds, I think that's a very good observation. I will say that in the accidental wetlands that I was studying in New York City and Phoenix, it did seem like water was probably the main vector for seeds. I Yeah, I didn't talk much about that work, but it's entirely possible that birds are facilitating this also, which is I think also kind of an aspect of self-organization where, ecological processes are facilitating the formation of these wetlands. But yeah, the seed banks appeared to be coming from people's lawns and were most likely waterborne from, lawn irrigation practices. But yeah, I would certainly be interested in knowing more about the role that birds are playing in the wetlands as well. And then what was the second part of the comment?
Perhaps human intervention, after that, then the most adapted plant species would be the most successful? Yes, no, maybe?
Yeah, it's really interesting that, I had a slide on this actually earlier in the talk that I didn't go through. But we often have this um, heavy focus in managing and planning natural areas on native plant species. So this was a study that a graduate student of mine did, looking at different wetland restoration planning documents in New York City over a number of years, just to see what priorities were kind of emerging from a key term search. And over again, biodiversity, specifically, habitat, wildlife, and concern over invasive species was emerging as one of the most important topics. But I could do just an entire talk probably just on this, but I think that you know, cities are increasingly kind of accepting that even though native plant species are desirable, it costs a lot of money to manage invasive species. And a lot of these accidental ecosystems are dominated by non-native species. So I think that it kind of depends on, let's see. Yeah. So this was another study that a student of mine did looking at restored accidental and constructed wetlands in terms of plant species composition. That's what these pie charts are. And then carbon storage, which is the bottom graphs, and nitrogen removal. And so, the constructed and restored wetlands were very heavily managed for native plant species and invasive removal. The accidental wetland was 100% invasive Phragmites. But there was no significant difference in their carbon storage capability or in their nitrogen removal ability. All of them were statistically, statistically the same, basically. And so I think it really comes down to priorities. Like, what are the priorities in terms of how you're managing this wetland? Is it to support native plant species? Or is it to improve water quality? Or is it to store carbon and, mitigate climate change? You know, sometimes invasive species can do just as good of a job. Sometimes they do an even better job than native plant communities. So it sort of depends on what the priorities of the city are. I don't know if that answered that question, but
Great. No, very robust answer. Susan Jarrett asks, wonderful presentation. Have you made any connections with Newport Bay Conservancy? And I'll take that to mean, would you like to have
yeah,
some connections with Newport
I
Bay
would love
Conservancy?
to. I would love to.
Okay,
Yes, I have not contacted them yet. I haven't had the honor, but I would love to. Yes. So
great.
please send me an email. I'll go back to that last slide again. Um, and I would love to meet and chat.
Great. Michelle Beltran says, I'm familiar with some of the work in central New York on green infrastructure. Onondaga County Save the Rain, and have been curious about whether the impact of green infrastructure on reducing CAFO events has been evaluated. Among other benefits of green infrastructure, are you aware of research in this area? Would love to learn more. Thank you.
Um, uh, so the CAFO meaning like the combined sewer overflow. Yeah, so Central New York, I'm less familiar with. I don't know if those programs have been successful in counteracting the CFO events, but or CSO events rather. Uh, it's entirely possible. I mean, I think that the problem in New York City, and I showed the study before where my students were finding basically no impact of the green infrastructure on CSO events, is because most of the subwatersheds in that watershed, so like the different sub sewer sheds basically of Newtown Creek are over 80% impervious. Most of them are over 90% impervious. And so even though you have all of these green infrastructure projects and like literally thousands of street trees that they planted there, it's just not enough in the scope of the extent of impervious surface to offset runoff. Um, it's possible that in central New York, um, those cities have significantly less impervious surface. I mean, New York City is like almost 100% paved everywhere. So I would imagine that green infrastructure projects that are situated in areas that have, less impervious surface might be more successful in offsetting CSO events. But yeah, the runoff volume is just too high when you get to that level of concrete.
Thank you for that. We have two questions from different anonymous attendees. I'll start with this one. Were you able to get business owners of industrial facilities on board during your community outreach? Do they tend to have an understanding of the part they have to play in reducing pollutant load?
That's a great question. No, my colleagues and I were working almost exclusively with nonprofit organizations and with government agencies. So we did not work with business owners. The one exception is so one of the park I didn't get to talk about this project, but one of the parks that I worked in, which was this Brooklyn Bridge Park project. That was a very exciting project because basically the community was engaged fully in not just kind of expressing their desires for that park, but also in designing the park itself. And that project, I believe, did involve some business owners. So the a nonprofit owned the park, but they were basically partnering with local businesses and community members to design the park. I think that local business owners probably don't tend to have an understanding of the part that they play in reducing the pollutant load. At least that was my experience in New York City. But I think that they do see the value in green space, and they see the value in providing sort of infrastructure for the community, like nature-based infrastructure. So yeah, I would love to engage you know, business owners more now that I'm in California in the work that I'm doing, especially because one of my focuses of research is going to be on turf removal and on landscaping. So I think that yeah, TBD, more to come. I guess I'll learn more about how business owners feel about their role in reducing pollutants. But I think there's probably not a lot of information or understanding that they are aware of, I would guess.
Speaking of familiarity with Southern California, California in general, here's a great question. Is there anything UCI can do as a campus to promote wetland restoration in our watershed?
Ooh, great question. Yes, I think so. So I was actually just chatting with Ian Swift a few days ago, who's with the Irvine Water Ranch District, and there are a number of wetlands in San Diego Creek and in some of the watersheds that do flow through Orange County. I think it would be, and I know that there's a restored wetland that is affiliated with UCI campus as well. But yes, I think more could be done to restore even more wetlands. I think particularly, I was showing how sort of climate change is interacting with water issues a great deal. So if we are to have more droughts, more extreme wildfires in the future, more extreme wet years like we've been seeing in Southern California over the last couple of years, that's going to have huge implications for wetland environments and water quality. So I think definitely more could be done, and stay tuned. I would love to do more. So I hope to promote that on campus into the future.
Great. Well, we're just about at the top of the hour. This has been a wonderful talk and a wonderful Q&A. A couple of quick announcements. We will have another colloquium in February. Stay tuned. We'll send out an email blast to everyone on this thread and also others. In addition, this talk has been recorded. So if you have friends or colleagues that were not able to avail themselves of this talk, please let them know. We'll post it on the Water UCI website very soon, and they'll be able to see it. And lastly, as you can see, Monica is very much beginning to become engaged in a lot of activities in our region. She'd love to get to know you. If you have ideas, things you'd like to share, work you'd like to share with her, ideas for collaboration, please contact her or contact us, and we'll make sure that you're able to be in contact with Monica. And thank you all for coming. And Monica, thank you again for a wonderful talk. And we'll have you back.
Thanks so much, Dave. Yeah, thank you.
All right. Thanks, everyone.